Now let's take the first question here. It says that in the given figure, PQRS is a rectangle, and if the value of PT is 16 and PQ is 24, as well as the angle is 90 degree, that this angle is 90 degree, we need to find the area of the rectangle. So let us assume that PQ, this is the length, and PS is the width, right? So we know that the area of the rectangle will be L into W. At the same time, we can find the area of this triangle PTQ. If we apply the logic that this is the base, then this will be the height, right? So it will be half base into height, correct? So this on calculation we'll be getting it as 192, right? And at the same time, if I drop a perpendicular from T on PQ, then this length is nothing but W. The other way of finding the area of the same triangle would be what? Half of, considering this L to be the base, then W would be the height. And this must be equal to what? 192. So straight away we can say that L into W, which is nothing but the area of the rectangle, will be double of this, which comes out to be 384. So option A becomes the right answer. Very easy question. All of us can solve it within few seconds, I would believe, right? Now let's just move to the next question. Now here the question says that the figure ABCD is a rectangle and the ratio of the length of EB, this length EB, to the length of BF, this is 2 is to root 3. So let me assume that this is 2 of A, then this will be root 3 of A, right? Now we need to find the ratio of length of BF, that is this, to the length of FC. So this we have to find, right? Okay. So let's come down to the triangles. So we are given 3 triangles here. This is the first triangle. In fact, this is the third triangle. 2 triangles, right? Not the 3 triangles. Sorry. The first triangle. This is the second triangle. In this triangle, this angle is 30 degree. This is 90 degrees. So, but obviously this will be 60 degree, right? Because this is 30, 60, 90 triangle. Similarly, here it is 30 degrees. So this will be 90 degree and this will be 60 degree. Now let us focus on this triangle and let us assume that this length is x. FC is x, right? We have to find FC. So in this triangle, 30, 60, 90 triangle, in fact, we can say that the length opposite to 30 degree is x. So this will be x root of 3 and this will be 2 of x, right? So the length opposite to 60 degree, that is DC, will be equal to x root of 3. Now DC is as equal to AB, right? Because this is a rectangle. So we can say this much portion, that is AE has to be x root of 3, that means this entire length or this entire length minus this length, which is what? 2 of A, correct? Now again, if I focus on this particular triangle, then we can say that the number opposite to 30 degree in this 30 degree, 60 degree and 90 degree, the length opposite to 30 degree is this much, which is x root of 3 minus of 2 of A. So obviously length opposite to 60 degree has to be root 3 times of it, which will be what? It will be 3x minus 2 root 3 of A, correct? So this length would be what? 3x minus 2 root 3 of A. Now, if you look at AD, then AD is equal to BF. So we can say this entire length must be equal to sum of these two, correct? So we can say that 3x minus 2 root 3 of A must be equal to root 3 of A plus of x. Now let's take x on the LHS and A portion, this term on the RHS. So we'll be getting 2 of x. This is equal to 3 root 3 by A, right? So definitely we can say the root 3A over x should be equal to 2 by 3. So option C becomes the right answer, because this is the value of PF and this is the value of FC, which we have assumed. The ratio would be 2:3. Now here it says that in the given figure ABCD is a quadrilateral and BC is equal to 4, BC is equal to 4, AD is equal to 2, and we need to find the length of AB. Now it's very difficult, looks like, because the quadrilateral has the angle 60, 60, 120, 150. So this angle, if you want to figure out, then this has to be what? 360 degree minus sum of these three, right? So if I take the sum of these three, this will be what? 120 plus 150 will make it 270. So this has to be 90 degree. This is the only thing which we need, which we have, and we have to get the value of AB. Now, important thing to note here is that this angle is 60, this angle is also 60, right? Now, if I extend BA and DC and let this point be E, then we can say that BCE, this will be a triangle, right? Wherein this angle is 60, this angle is 60, so obviously this angle too will be 60 degrees. So we can say that this is a equilateral triangle, right? This is 90, correct? This will be what? 180 minus 150, so this is 30 degrees. So this is 30, 60, 90 triangle, and this length is 2. So 30 degree, 60 degree, and 90 degree in this triangle. Length opposite to 30 degree, if it is 1, then length opposite to 60 degree has to be root of 3, and length opposite to 90 degree has to be 2. Correct? Here the length opposite to 60 degree is 2. If this is 2, then definitely length opposite to 30 degree will be 2 divided by root of 3. That means this length is 2 divided by root of 3. This much length. Correct? Now since this is an equilateral triangle, we can say that BE will be equal to how much? 4. But we need to find this length. So we can say that this entire length BE minus AE, that should be the value of BA. Correct? So BE is 4 minus AE, we have already identified that this is 2 under root of 3. So the answer should be 4 root 3 minus 2 divided by root of 3. So option B becomes the right answer. Now let's take the fourth question. Here it says that ABCD is a parallelogram. E is a point on AB such that this is the ratio given. AE is to B is 2 is to 3. So let us draw a parallelogram. Say this is the parallelogram ABCD. This is A, this is B, C and D, right? And E is a point on AB such that they are in the ratio 2 is to 3, correct? Now line EF is drawn parallel to AD. So EF is drawn parallel to AD, right? And G is a point on BC such that GB is to GC is 1 is to 4. Now we need to find the area of triangle DEC to the area of triangle EFG. Now we have to join DEC, right? So let us do that. DEC and EFG. So this need to be joined, right? Like this. Now let us assume that the area of the parallelogram ABCD is equal to 5 of A. The reason I am considering is 5 of A is that the ratios are in the ratio 2 is to 3, right? So 2 plus 3 is 5, and here also 1 plus 4 is 5. So there is likely that 5 of A will be divisible by some of the terms which we'll be using later. So this is my assumption, right? Now if I want to consider the area of triangle DEC and I want to find the area of this in terms of A, then clearly it will be half of 5 of A, right? Why so? You can see that if I join DB, then definitely this is the diagonal and it will divide the parallelogram into two equal areas, right? That is area of triangle DBC, that will be equal to area of the triangle ADB, right? Because this is a diagonal. And if we compare DC and AB being parallel, if we compare DBC with triangle DEC, we are comparing DBC and DEC, then we can say that both are between the same parallel line, having the common base, right? Having the common base. So definitely both these areas or the area for both these triangle will be same, right? Because they have the common base, and the height will also be the same because these are between the parallel lines. So we can say that the area of DBC will be equal to area of ADB, which is nothing but effectively half of the total area of the parallelogram ABCD, correct? Now similarly, if we look at the parallelogram ADFE, in this parallelogram, we can say that this will be a parallelogram, of course. We can say that this is length 2, correct? So this 2 will be length 2. And if you consider the entire parallelogram ABCD, then this length is how much? 5 or 5 portion. This is just 2 portion. The height for both the cases, both the parallelogram is same. So we can say that the area of this will be 2/5 of the total area of the parallelogram ABCD, correct? Which effectively is nothing but 2 of it. And thereby we can say that the portion of the parallelogram, the next parallelogram, that is EFCB, this will be equal to 3 of A. Now again, in this parallelogram, we see that the two triangles EFG and ECB both will be having equal areas, and that will be half of this. Why so? Because both are between the same parallel line having the common base, right? So triangle EFB, this will be, in fact, EFG, I have to take triangle EFG will be equal to half the area of 3A, which is equal to 3 by 2 times of A. We have calculated this. We have calculated the area of triangle DBC, which is equal to half of 5 of A. You have to take the ratio of DEC. DEC would be 5A by 2 and divided by 3 by 2 times of A. So clearly the ratio is 5:3, which is option number D. Now in this question, it says that a circle touches all four sides of the quadrilateral PQRS. The three sides are given and we need to find the four sides. It's a very, very easy question because we use the property that if there is any quadrilateral like this, wherein all four sides are tangent to the circle, right? All four sides are tangent to the circle, then such kind of quadrilateral is called tangential quadrilateral. So here if it is P, Q, R and S, right? Then the property says that some of the opposite sides are equal in such case. That is PQ plus RS. That will be equal to PS plus QR. This is the property we'll be using it. 4 out of 3 is already known, so 4 can easily be identified, right? So here the value of PQ is 11. RS is to be identified, right? And we actually, this question says that find the fourth side. No? Find the value of RS basically. Is equal to PS. The value of PS is given to us as 8 and the value of QR is given to us as 12. So RS will be equal to 8 plus 12 minus 11, which comes out to be 9. So option B becomes the right answer. Very simple question. The only thing you need to remember is this property. Now in this question, it says that in the given figure below, P is a point inside the square PQRS, right? And PC is equal to 6, QC is 8 and SC is 10, and we need to find the value of RC. Now again, we can say that square is nothing but a rectangle, right? We can say that square is also a rectangle, and we'll be using the property of rectangle that in a rectangle, if there is any point which is inside, say this rectangle, say point, this is P and this is A, B, C and D, then if we join the vertices with these points like this, then we have the relation that AP square plus of CP square is equal to BP square plus of DP square. Now square is also rectangle, so we can apply the same logic here. So we can see here is that PC square plus, if I join RC, then it will be RC square will be equal to SC square plus QC square. Now 3 out of 4 is given. PC is 6, so it will be 6 square plus RC square. SC is given to us as 10 and QC is given to us as 8 square, correct? So RC square would be what? This will be 100 plus this will be 64 and this is 36, so we'll be deducting 36 out of it. So here we'll be getting it as 128, right? So the value of RC will be equal to under root of 128, which which is equal to 8 root of 2. So option C becomes the right answer. Again, a very easy question provided we know these properties. That's why in quadrilateral, the properties are very, very important, specifically related to diagonals. Now let's take the seventh question. Here it says that the area of the trapezium is given to us and the perpendicular distance between the two parallel sides is 12. That means the height of the trapezium is given, right? So let us draw the trapezium, something like this. So this is the trapezium wherein the height is 12, right? And these are the two parallel sides. And one of the parallel sides is 60% length of the other parallel side. So let us assume that if this is A, then this will be 60%, or let us assume that this to be A, then this is 60% of the other parallel side. So this will be 0.6A, right? 60% of A will be 0.6 of A. We need to find the length of the larger side. That means we need to find the value of A. It's quite an easy question. Directly we can apply the area of the trapezium. We say that half sum of the parallel sides into height is equal to the area, right? So clearly we can see that this will be 1.6a is equal to 1920 multiplied by 2 divided by 12, correct? Which on calculation will be getting it as, this should be 320, right? So the value of a would be 320 divided by 1.6, which comes out to be 200. So 200 is the answer for this question. Very easy question, direct application of the formula, and we'll be getting it within a minute. Now let's take the eighth question. Here we say that Ajay and Amar, they inherited a rectangular field of the area of 1000 square meters. So let us draw this. So this is the rectangular field. And if they decide to split the land into two halves by dividing it into a single straight line, then find the approximate minimum cost that Ajay would have to incur to fence half the land at the rate of 1 meter per rupees 1 meter rupees 1 per meter, assuming that Ajay bears the complete cost of fencing. Now in this question, what we have to do is that we have to ensure that this straight line so drawn has to be the of minimum length, and the rectangle should get divided into two halves. One way of dividing the rectangle is along the length, right? In that case, this length would be higher than if I draw along the width. So to ensure that the length is smaller, let us divide this rectangle into two equal halves along the width. In this case only, the rectangle will be divided into equal areas and the length of fencing would be minimum. By symmetry we can figure out, right? Now Ajay has to bear the complete cost of fencing. For example, say assume that this part is for the Ajay. So Ajay would be fencing this, then this, right? It would be fencing this square. If not a square, obviously this rectangle I would say, not necessarily a square. So let us assume that the length is L and the width is B. Then the area L into B is given to us, that is 1000, correct? Now the perimeter of fencing for Ajay would be what? Half this length, because this is at the midpoint, because we are dividing into equal parts, so we have to take this length into the midpoint. So this will be L by 2, this 2 would be L by 2, and this is B. So clearly the sum of these these four numbers would be equal to 2B plus of L, right? So we have to minimize this. So clearly we are having the product and we are having in the sum. So we can apply AMGM concept, that is arithmetic mean is greater than equal to geometric mean. In that case, let us assume that this is the first term, this is the second term, divided by 2 has to be greater than equal to their geometric mean. Now L into B is 1000, so we can multiply it here. So it will be equal to under root of 2000. Or we can say that 2B plus L is greater than equal to 2 times of under root of 2000, which on calculation will come close to 90. So the minimum perimeter will be 90 and the rate is 1 rupees per meter. So obviously the answer would be rupees 90. So option B becomes the right answer. Very important question. It cannot be categorized as only geometric question. We have to apply the logic of maximum minimum also.